Hello and welcome to physics video lecture series. We were discussing the variation of various quantities with time, and I was telling you how the potential energy in simple harmonic motion varies with time. So we know that potential energy is half kx square, and x as a function of time t is nothing but a sine omega t. So half k square sine square omega t. Now the previous quantities x as a function of time t, or v as a function of time t, a as a function of time t, f as a function of time t, all these quantities were sinusoidal. So they were positive also and negative also. But potential energy as a function of time t, this is going to have a slightly different behavior, because if you see, this quantity can never be negative. All the quantities are positive. Value of sine varies from -1 to 1, but this is a square, so it will always be positive. So if you draw the graph of potential energy, it will vary like this. And these are the peak values. It will be half k a square. Okay, so this is the maximum value, and it will come at, you can draw this point intuitively. The maximum potential energy is when the spring is extended. If it is starting from the origin at t is equal to 0, the mass is at the origin. At t by 4, the mass is at the extreme position, so the potential energy is maximum. Again, this is the mean position, so the potential is 0. This is the other extreme position, so potential energy is again maximum. And finally, time t. Okay, so this is the variation of potential energy with time t. So if I ask you kinetic energy versus t, so kinetic energy is nothing but half m v square. So this will be half m omega square a square cos square omega t, because velocity is omega a cos omega t. So half m omega square a square cos square omega t. Again, this quantity will never be negative, it is always positive quantity. So if you try to draw this graph, at t is equal to 0, the velocity will be maximum because the particle is at the origin. It is moving in the positive x direction with maximum velocity. So the graph will be like this. This is t, this is t by 4, this is t by 2, 3t by 4. This is the maximum possible kinetic energy, which is half m omega square a square, and this is again half k a square, because m omega square is nothing but k. And it all makes sense, because potential energy and kinetic energy, they convert from one form to the other. The total energy remains constant. So at the initial position, when potential energy is 0, all the total energy is in the form of kinetic energy. So half k square is the kinetic energy. At t by 4, the particle is at the extreme position, the kinetic energy is 0, and all the energy is in the form of potential energy. If I draw the graph of potential energy on kinetic energy itself, it will look something like this. Just superimpose the previous graph, and this is pretty obvious. So when the kinetic energy is maximum, potential energy is 0. When kinetic energy is minimum, potential energy is maximum, and so on and so forth, such that the sum of the kinetic energy and potential energy at any instant of time is constant, and that value is half k a square, which is the total energy of the simple harmonic motion. So if I draw the total energy as a function of time t, this will always be half k a square. So the total energy will not change at all, it will be a straight line. half k a square, and we have to draw it till capital T. You can just draw the points, it's no use because total energy is constant, but draw the final point T. Okay, so this is total energy versus T. So I've told you how the graphs of various quantities, velocity, position, total energy, kinetic potential, acceleration, force, etc., they vary with position and time. Okay, so in the next video lecture we will come up with something new, so stay tuned. And again, if you have any doubt, please comment in the comment section, like, subscribe, and if there is any topic on which you want me to make a video, then please let me know. Okay, thank you, stay tuned, have a nice day.